So another thing I want to talk about is the invisible intelligence barrier, as I call it, which is the thing that prevents you from learning new skills because you are worried that you are not intelligent enough to learn them. I've seen this so much, and I've wanted to do a video like on the main channel talking about this, but discussion content really falls off on the main channel. So I feel like I'll put it here instead. Like, just to keep it simple, you're definitely smart enough to learn the skills that you're afraid to learn. The thing is, most knowledge is simple. Complex mathematics is simple. Quantum mechanics is simple. Rocket science is simple. It's not the actual knowledge which is scary. Holding it in your mind doesn't cost much. You don't have a tax for your brain. The problem is the process to get it there, the process to build those neural networks, those pathways for you to understand. You know, there's that saying, I don't know if it's like an Einstein saying or something, but you know, that if you don't know how to explain something simply, then you don't understand it well enough. And I feel like that's definitely true to a certain degree. And in some of my previous work, I've tried to take different approaches to explaining content, and one example of that would be the intro to coding video, where I really went out of my way to explain abstraction, classes, functions, variables, and stuff like that in a way that was different to how I read them in early books like Beginning Programming for Dummies or C++ for Dummies. And in most of my other educational content, I always try and make sure that we start off with something that's very visually impactful, because I know that I learn very visually as well. Not everyone does. And it's been interesting talking to people that have cognitive differences as well, especially in the Blendedness podcast. I remember there was one conversation where I tried to explain how I count numbers, which is very weird. I count them in extremely visual ways. I visualize the face of a die or a dice, depending on what word you want to use, where I count 1, 2, 3, 4, 5, 6, 7, 8, 9, and I can like feel their positions and kind of like see the dots there. I don't generally just count 1, 2, 3, 4, 5, 6, because I feel like it just escapes my short-term memory really quickly like that. But I feel like one major difficulty for people is learning how they learn. If you can learn how you learn stuff, like effectively, properly, not just learn how other people think you should learn, then you'll be in a much better position to adopt new skills. And I think part of the solution to discovering that is really assessing yourself, watching yourself as you're learning new skills. At what points do you give up learning? Is it when frustration spikes up? Is it when you don't understand something? What are you watching that you don't understand? Is it a YouTube video? Is it someone showing you a demonstration? At what point do you stop understanding it? Is there something visually they're doing? Can you not see the result while they're explaining it? Is that the problem? If you could see the result, would it be different? So you question things like that, because then you might be discovering alternative ways for you to learn those skills. Another thing to keep in mind is how you make projects. And I talked about this recently as well in my modularity talk, which I actually recorded like half an hour ago, but we pretend that it was like a few days ago, where I talked about how when I want to make large scale projects, I don't just tackle them head on. Like, I'll identify the smaller components of them that need to be made, and then maybe I'll knock 1 or 2 of them off, like the first time round, and then I'll get bored and go around in a big old circle working on other projects. And when I come back around, I can assess it through a different lens. The lens of, I've already created these pieces. Now what can I do? Can I get closer to the final result? And if not, what other pieces can I achieve? So we knock some of those off and then come all the way back around again. Maybe some people can sit there and they can do the whole thing in one go, but that's not how my brain works. You know, very short attention span. The invisible intelligence barrier is like this fake wall that you have put there because the idea of going from 0 to 100 in one sitting is very daunting. Of course, you're never going to be able to understand how to program something without any programming experience in one sitting. It's very difficult to build the neural pathways to allow that understanding. Once you understand the philosophical concepts behind instructional logic, abstraction being the key one, it's the main philosophical concept for technical design that I bury into all of my education, then you equip yourself with the mental tools to better onboard that information. It's also extraordinarily useful using anecdotes when teaching people complex subjects, especially if they're good anecdotes. Really bringing in effective anecdotes into your educational work is, I think, an interesting skill that not a lot of people have. And I like to think that I do have it to a certain degree. Alright, calm down, Bigot. When I did the Python crash course for Blender, I remember there was one where we had spent so long going over like everything line by line, and then when it came to taking the jump between taking the script you'd made and then turning it into a proper add-on which could be packaged, there were so many things which suddenly came into frame. Like all this weird metadata, these class structures and registering and unregistering functions, and it was all stuff that hadn't been approached yet. It was too much to onboard at once for someone that had never done that ever before. So I was like, okay, well, forget the rest of this. This is your Amazon delivery packaging. You know, if you've got a parcel, it's got an address on it, you know, it's got all this extra data. You don't care about that. You just care about what's inside the parcel. This is the labeling. This is the important labeling. And when you start to give concepts like that real life connections, it becomes less scary because they stop seeing it as, I need to understand every line. What is this? Oh, I don't understand it, so therefore I'm a failure. It becomes, well, I don't really care about labeling for packages in real life, and that labeling's not scary, so I'm not scared, it's just labeling. It might sound stupid, but that's how a lot of people think about it. I think to be an effective educator, one thing you should try to do is remove that fear by using anecdotal connections to people's lives, and just show them that, hey, I know that understanding this can feel like a scary task, and it might be a bit of a challenge if you've never done it before, but you do have the potential to understand it. So I guess the message of this video is, try not to be afraid of the invisible intelligence barrier that you're putting up in front of skills that you don't think you're capable of understanding. Believe in yourself, you may just have not found the right approach for it yet, for building those neural pathways. Maybe you just haven't found the right way to connect it to a different aspect of your life to help it make more sense. But anyway, I hope you found this interesting. I'm going to leave it here for now. So I hope you're doing well, stay safe, and I'll see you next time.